In section 3.5, we're talking about rational functions, just graphs that consist of algebraic fractions. We had these as guidelines for finding everything important that you need to know about the graph before we graph it. We found vertical asymptotes. What gives you vertical asymptotes? What tells you where the vertical asymptotes are? What makes the denominator 0? And then we found horizontal asymptotes by using this theorem on horizontal asymptotes, which depends on the degree of the numerator and the degree of the denominator. We said if the bottom of a fraction is getting big faster than the top, if the denominator has a higher degree than the numerator, then the horizontal asymptote is 0. What if the numerator and denominator have the same degree? Ratio of the leading coefficients, and if the degree of the numerator is higher than the degree of the denominator, what does that tell you about horizontal asymptotes? Top of the fraction is getting big faster than the bottom of the fraction. There's not going to be a horizontal asymptote. Those y's are going to infinity because y's, the numerator is getting big faster than the denominator. Well, today we have a special case of this third situation. The third situation says if the degree of the denominator is greater than the, if the degree of the numerator is greater than the degree of the denominator, there is no horizontal asymptote, but there may be something we call an oblique asymptote. So that's where we are. Let's talk about oblique asymptotes and when they occur. If f of x is a rational function where the numerator is 1 degree higher than the denominator. We've already said if the numerator is a higher degree than the denominator, there's not going to be a horizontal asymptote. But there is an oblique asymptote if the numerator is just 1 more than the denominator. Now, if I divide any rational function, if I divide x to the 4th, blah, 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 divided by x cubed, blah, 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 if I actually do that division, what degree will my quotient be if I divide an x to the 4th by an x cubed? It'll be first degree. Or if I divide a 10th degree by a 9th degree, it's going to be first degree. When you divide and get that first degree function, that linear function is your oblique asymptote. That's what the rest of that sentence says. If f of x is a rational function where the numerator is just 1 degree higher than the denominator, there is no horizontal asymptote, but there's an oblique, also called a slant asymptote. You find it by dividing. If the numerator is 1 more than the degree of the denominator, when you divide, you get a linear function, and that linear function is your oblique asymptote. Now, I want to give you some help on this division. There are 3 cases, 3 different types of division that we may have to do in order to find the equation of the oblique asymptote. The first case is if the denominator is just a monomial, like on number 39, the denominator is just 2x squared. If I tell you to divide 8 minus x cubed by 2x squared, you can just break that into 2 different terms. And then you can simplify each one of those terms. You can put the 8 over 2x cubed minus the 1x cubed over 2x cubed, and that simplifies to negative 1/2 x plus 4 over x squared. This part, negative 1/2 x, y equals negative 1/2 x is the oblique asymptote. Y equals what you get when you do the division. That's your oblique asymptote. And that is one possible way that you could handle that division. Now, I'm not going to finish that problem because it's in your homework. When you get to number 39 on your homework, you can look at that to remember how we found the oblique asymptote. I will do these 2 so you can see how to graph the oblique asymptote. As soon as I looked at number 38, I said, well, what's the vertical asymptote? It's whatever makes the denominator 0. And remember, it's not just a number, it's an equation. So not just 2, but what? X equals 2. X equals 2 is the vertical asymptote. And then when I went to the B part to try to figure out where the horizontal asymptote is, I said the degree of the numerator is greater than the degree of the denominator. What does that tell you about horizontal asymptote? There isn't one. But then bells and whistles go off to remind me if there isn't a horizontal asymptote, but the degree of the numerator is just one more than the degree of the denominator, then there's a slant asymptote or an oblique asymptote. And you find that by division. We're dividing by x minus 2. We could use long division, but if we're only dividing by x plus or minus a constant, that's set up perfectly for synthetic division. Synthetic division, where we put 2 in the box and the coefficients of the numerator out beside the box. And then we started our multiply, add, so we ran out of stuff to multiply and add. This was the bottom row of synthetic division. What's this 3 on the end? That's the remainder. The remainder is not part of the oblique asymptote. The oblique asymptote is just the quotient, which is 2x plus 3. So y equals 2x plus 3 is the oblique asymptote. Let's go ahead and graph those two asymptotes and then we'll get our intercepts. The vertical asymptote is x equals 2. How do you graph the oblique asymptote? It's just a line. We're going to plot the y-intercept at 3. The slope is 2, so we're going to count up 2 over 1. And I'm just going to make that a dashed line rather than a solid line because it's an asymptote. Wish I'd left a little bit more room there. But there's my oblique asymptote. How do we find the y-intercept? Let x be 0. Is that easier in factored form or original form? So let x be 0. I think it's easier to let x be 0 in this original term. I can just cover up all the terms with an x in it. -3 over -2 or +3 halves. The y-intercept is when x is 0, y is 3 halves. And then how do I find x-intercepts? Let y be 0, and with a fraction, what makes a fraction equal 0? Whatever makes the numerator 0. That's easier to see in factored form. In factored form, I could tell if I set each one of those factors equal to 0, then I'd get 3 halves, 0 for one of the x-intercepts, and 1, 0 for the other x-intercept. Is this 0, 3 halves the same as that 3 halves 0? No, that's just a coincidence. But that's 2 different points. Let's go ahead and graph those intercepts. Y-intercept is 0, 1.5. X-intercept is 1.5, 0, and 1, 0. Something is bugging me. Let me check real quick. Yes, that factor was x plus 1, so that's supposed to be negative 1, 0. Positive 1.5 and negative 1 are your x-intercepts. Now, just like last week, I'm training my brain to see what's going on to the left of the vertical asymptote, what's going on to the right of the vertical asymptote. So I'm going to put my pen or my pencil down right here and saying to the left of that vertical asymptote, the graph can either be above the oblique or below the oblique. Do I have anything that tells me where that piece of the graph is, or do I need a test point? Either above the oblique or below the oblique. Can you see which without using a test point? Jeremiah, you can. What is it? It has to be below because of all of your intercepts. So to the left of the vertical asymptote, graph looks like this. And it does approach both the oblique asymptote and the vertical asymptote. Now I'm training my brain to see what's going on to the right of that vertical asymptote. The graph can either be above the oblique or below the oblique. Do you have a way of telling which one, or do you need a test point? I just can't hear you. You can actually get by without a test point here, because what would have to be true if the graph was below the oblique? What would there have to be if the graph was below the oblique? There would have to be another x-intercept. It would have to cross the x-axis over here somewhere. And I know there's not an x-intercept. So the other piece of the graph is above the oblique. And I want to show you on the TI-83 why we're even talking about this. If I'm going to have this calculator in calculus, why do I have to be able to figure this out by hand? I needed a parenthesis right before that X. On a standard window, that looks like the whole graph. I can kind of guess that there is a vertical asymptote at 2. It looks like the right side piece of that graph is getting going to negative infinity as x approaches 2 from the left. So I can definitely see the vertical asymptote. I can't see the oblique asymptote at all. And I don't realize that I'm missing half of the graph. I have to zoom out. Let's make my y's go from negative 100 to 100, counting by tens. There's the other piece of that graph. And if I plot the oblique asymptote with it, 2x, what was it, 2x plus 3? Then I can see the oblique asymptote and both pieces of the function. All right. So when is it that you're going to have an oblique asymptote? When the numerator is just 1 degree higher than the denominator. How do you find the slant asymptote? By dividing. And so far we've had 2 cases. We had when the denominator is a monomial. You can divide just by breaking that into separate fractions and reducing each term. And we've seen when the denominator is just x plus or minus a constant, we can use synthetic division. But what about number 40? Can I use synthetic division if I'm dividing by x squared minus 9? Synthetic division only works when you're dividing by x, plain old x to the first, plus or minus a constant. If you're dividing by x squared minus 9 and you can't use synthetic division, then what are you going to have to use? What do we use when we can't use synthetic division? Kind of horrific long division. And you may not have even seen long division. I know that I don't cover it in college algebra, so I need to demonstrate that for you. But you just need to know in the homework when you can and cannot use synthetic division. I can't use synthetic division here. So using long division, it's going to look like dividing a binomial into, actually, even if I was using synthetic division here, I'd have to notice I'm missing some terms in the numerator. I'd have to put zeros in for my missing terms. So I'm going to go ahead and put in a 0x squared and a 0x to the first. X cubed, x squared, x to the first constant. And in the denominator, I'm missing a 0x. So this is going to look like, in basic math, dividing a 3-digit number into a 4-digit number. We're dividing a 4-term polynomial by a 3-term polynomial. It's going to look like dividing, let's say, 252 into 4,758. I'm dividing x squared plus 0x minus 9 into x cubed plus 0x squared plus 0x plus 1. All right, in basic math, when I'm dividing 1,000 something by 100 something, first I just pay attention to the first digits. I say, how many times will this go into this? Or what do you multiply times x squared to get x cubed? Just x. The next step in long division, after you've divided, you multiply this x times each one of those 3 terms. X times x squared is x cubed. X times 0x is 0x squared. And x times negative 9 is negative 9x. What's the next step in long division? Subtract this whole guy from what's above it. And when you subtract, you're really distributing a negative. And that's why we say change the signs. It sounds kind of like hocus pocus, but really we're distributing a negative 1 here in order to subtract. So I have x cubed minus x cubed is 0. I have 0x squared minus 0x squared is 0. I have 0x plus 9x is 9x. And then what's the next step? bring down the 1, and start the whole process again. Does x squared go into 9x evenly? No, x squared won't divide into 9x evenly. That means that's my remainder. The linear portion, just the x, is my quotient. So what's my oblique asymptote? No. The oblique asymptote's not the remainder, it's the quotient. Y equals x, because that's the quotient. My oblique asymptote is y equals x. What about vertical asymptotes? There are 2, positive 3 and negative 3. Make sure you give me equations, not just numbers. X equals negative 3, x equals positive 3. And let's go ahead and graph those asymptotes. X equals negative 3, x equals positive 3, and y equals x. What's the y-intercept of that graph? Can you see it? Because and it's easier to see that before I factored, if I let both of those x's be 0, I just get y's negative 1, 9. So that's the y-intercept, 0, negative 1, 9. And it's easier to see my x-intercepts in factored form. Definitely what's one of my x-intercepts? All right, you took the easy one, left me with the hard one. I wonder if there's a solution to x squared minus x plus 1. I know it won't factor any further. There aren't any factors of 1 that have a difference of 1, but does not factoring further automatically mean there's no solution to this? No. If I can't find the solution by factoring, how would I have to find the solution? Quadratic formula. But I think if I took those coefficients and plugged them into the quadratic formula, under the radical in the quadratic formula, I'd have b squared, that would be 1, minus 4ac. That gives me a negative under the radical. I needed to check that, but I can see now that I have a negative under the radical, and that means this doesn't give me any x-intercepts. There's only one x-intercept, and it's at negative 1. If you don't have a horizontal asymptote, you don't have to worry about the E part. If you don't have one, the graph can't cross it. So let's graph those intercepts. Negative 1/9 is just barely below the x-axis, or barely below the x-axis. X-intercept is negative 1, is right there. And I'm going to train my brain to look to the left and to the right of each vertical asymptote. That's x equals negative 3. The graph either has to be above the oblique or below the oblique. Do I have anything that tells me which one it is? Why not above? There would be another x-intercept over here if it was above. Now, yay, if you can figure that out without a test point. If you can't figure that out without a test point, then use a test point. Which which you really shouldn't need to because there's no other x-intercept to the left of x equals -3. That means this piece of the graph has to be there. I'm going to take the other easy part before I worry about that hard middle part. What about to the right of +3? The graph either has to be above the oblique or below that oblique. Can you see which one, or do you need a test point? Has to be above, again, because you know there's no x-intercept over here. So this little piece of the graph has to be right there. Now what about between? Before I think between, I'm going to think to the right of that. To the right of that, the graph either has to be coming down from above or coming up from below. Can you tell which? To hit that x-intercept, it's going to have to be coming down from above. And then to hit this y-intercept, it's going to have to keep coming. What do you think that's going to look like between its asymptotes? What other graph that we know do you think that's going to end up looking like? It's going to be a vertical snake going downhill from left to right, means it's going to be -x cubed instead of +x cubed. But that's what it looks like between the asymptotes. It was x cubed plus 1 over x squared minus 9. I'm going to go ahead and put that oblique asymptote on there as well, y equals x. Won't you be happy to have that calculator? Yeah, but if you don't know how to figure this out, well, number one, you wouldn't have known there was an oblique asymptote there if you didn't know if the degree of the numerator is 1 more than the degree of the denominator. There's always going to be an oblique asymptote, and you have to know how to find it by some sort of division, either breaking the fraction into baby fractions and simplifying, using synthetic division, or using long division. All right, the only other thing that we need to look at is something that actually happened to you last night, and I didn't prepare you for it. Kind of on purpose, I wanted you to discover it on your own. But number 44 on the handout, at first glance, I don't recognize anything special about it. I can already tell you, does it have a horizontal asymptote or an oblique asymptote? The degree of the numerator is the same as the degree of the denominator. It has a horizontal asymptote, and where is it? That's not what, if the degree of the numerator is the same as the degree of the denominator. It's the ratio of the leading coefficients. These leading coefficients are both 1. So the horizontal asymptote is going to be y equals 1. In general, I always want to factor that right from the beginning. So I factored the numerator, I factored the denominator. And only when I did that did I realize that this original function will simplify because there's a common factor and I can cancel common factors. As long as I leave myself a note out to the side, this fraction equals this fraction at all points except for where x equals 3. I can let x be 3 in this simplified form. I can't let x be 3 in this original form. So what does that mean about the graph when you cancel out a factor that has an x in it? Can you just ignore the fact that you canceled out an x minus 3? That actually means there's a hole in the graph at 3. And how can I find what the y value of that hole in the graph is? You can plug the 3 into the simplified form, you just can't plug it into the original form. If you put 3 into that simplified form, you'd have 5 over 4. So that hole in the graph is at the ordered pair 3, 5, 4s. The graph of this original function looks identical to the graph of this simplified function in every single way except there's a hole in the graph at 3, 5, 4s. Once you've identified that, you don't even have to look at the original form anymore. You look at the simplified form and you say there's a vertical asymptote where? Vertical asymptote's what makes the denominator 0, -1. The vertical asymptote is x equals -1. The horizontal asymptote is y equals 1, the ratio of the leading coefficients. What's the y-intercept? If I let x be 0, I get y is 2. What's the y-intercept? Or excuse me, the x-intercept? Laura, where do you get an x-intercept? Flip your notes over and look at the other side. How do you find the x-intercept? Right. Look right here, Miss Laura. You're absolutely right. Find the x-intercept. You let y be 0, and what makes a fraction 0? 0 where? 0 in the numerator. So what is the x-intercept of this? So we're looking for what makes the numerator 0. What makes this numerator 0? So that's the x-intercept, -2, 0. When we have a horizontal asymptote, then the E part applies, and we have to say, does the graph cross the horizontal asymptote? How do we answer that question? In last night's homework, most of the graphs didn't cross the horizontal asymptote, but then I bet you had 1 or 2 where it did. How do we find out if the graph crosses the horizontal asymptote? set the function, and in this case, the simplified function, equal to this constant in the horizontal asymptote and just see if there's a solution. So the answer to this question comes from setting x plus 2 over x plus 1 equal to the 1 from the horizontal asymptote. If I multiply both sides by x plus 1, I have x plus 2 equals x plus 1. Does that have a solution? No. You subtract x from both sides, you have 2 equals 1. That's never true, no matter what x is. So what's the answer to the question, does the graph cross the horizontal asymptote? No. So here's x equals -1, the vertical asymptote. Y equals +2. No, I'm sorry, +1. Kind of got off track there. Y equals 1 is the horizontal asymptote. The y-intercept is 2. The x-intercept is -2. We just need to look at that graph to the left and to the right of the vertical asymptote. To the left of the vertical asymptote, the graph either has to be above the horizontal or below the horizontal. Can you tell me which one without using a test point, Jeremiah? Yeah, you have an x-intercept that's below, so that piece of the graph has to be below and approaching both intercepts, or both asymptotes. And then to the right of the vertical, the graph either has to be above the horizontal or below the horizontal. It has to be above to hit that y-intercept. All right, so the two things we learned today, we learned when there's an oblique asymptote and how to find it using one of our 3 methods of division. And then we learned, just verified and talked about what we saw in last night's homework. If you cancel out a factor that has an x in it, you can just graph the new function rather than the original function. But there's going to be a hole in the graph at whatever makes that factor you canceled out 0. All right, I am probably going to take up all this homework tomorrow. So you just have 4 more problems to do in addition to the ones that you've already done. And number 39, don't forget when you get to it that we started it right here. All right, one other thing from my people who are retesting Friday, I need your 4 problems that you did Friday, Saturday, and Sunday. So you should be handing me 3 pieces of paper, 4 problems each. Yeah, Friday, Saturday, Sunday.
You're talking about now.
Yes. Yes. If you don't have them right now, you could get it to me later today, but it would have to be today. You need later today, Miss Megan? Miss Laura, later today?
I have 2, but I need to.
Okay.
Yeah, I need to finish one.
Okay. All right, make sure the answer's right. You've checked it when you hand it to me. If you miss it, then rework it on the back. You want to ask me something?
Yeah, it was just on this one in the back of the book. It's in segment 1.
Oh, okay. And this is absolutely fine with me.
Except for it's not right.
Okay, we'll have to figure it out then. Mr. Andrew, are you digging for those problems? Okay. this was two, it looks like 2.3. It's about line, 2.3, number 16.
Number 16 is even.
Okay. You're right, it is, which means I didn't mean for you to put it on your card. Let's see. You said -4 minus 2 is -6. 3 minus -1 is 4. -6 fourths reduces to -3 halves. Y minus 2. Oh, this must have said
Yeah.
we gotta, let's see the directions. Because I don't know if it says find a line. If it says perpendicular bisector, then I'll tell you why you missed it.
Yep. I bet that's what it was.
Okay,
I guarantee that's what it was.
all right. You may be able to tell me why you missed it then.
75.
Oh, and here's why I put it on your sheet. All the answers are available for review exercises, have odds and evens in the back. So look at chapter 2 review and it will have number 16, but I know you've missed it because perpendicular bisector not only has to have slope that's the opposite and reciprocal, but what point does it have to go through? Yes, yeah,
Okay.
that's why you missed that one.
So it's okay if it's in this form.
Yes, absolutely. That's the form I actually prefer it in.
Okay. Awesome.
All right, Miss Laura gave you that. Yes.
What time are you here today? Because I did it, but I didn't bring the binder, and that's what I put it in.
My office hours are on the syllabus and on our momentum page.
Okay. Cool.
And even if I'm not here, you can hand it to them at the front desk and ask them to put it in my mailbox, and they will. Just make sure it's got your name on it.
Awesome. Thank you so
You're
much.
welcome.
I don't think I lost that one paper and it wasn't posted, so.
Oh, one piece of paper. Okay.
Sausage.
Let me see. You have Saturday, Friday, Saturday, Sunday, and you have 4 problems randomly chosen. Have you checked all the answers? In the back of the book, you're sure all of them are right? But if that's from the review, it's not?
I didn't have that one piece of paper, so I didn't have time to write. So I did. I didn't get it correctly, so I had the numbers in there, so I should have looked through.
Oh, you found some because you didn't have that paper. Okay, and you happen to do, was that an, oh, it's an odd.
Oh, 11. So some of these I know I didn't.
Those are all odd. I don't see the evens. Oh, okay, good. Tell you what, if you want to double check that all those are correct, then give it to me in a few minutes. If you're confident that they're all correct, then I'll go ahead and take it. Okay, all right. Oh, okay. All righty. Were you able to do these without, looking at examples? Okay. Would you like to come with me so I can give you, another copy of that piece of paper?
Yes.
You didn't put the page numbers on your index cards?
No, you said, just do that later. You said, okay, that's fine, just do it
Okay.
later and then.
Okay. Let
I
me,
got actually part of the time in this paper, so.
okay.